Hello, we'll make a start. Welcome to session 5 on secret messages. And I'm Piers. You may have seen me on some of the previous 4 o'clock sessions. And I'm joined by Stephen. Do you want to introduce yourself?
Hi, yeah, I'm Stephen. I work for Redgate on the service test team, so generally helping out staff with any technical issues they have.
Wonderful. Okie-doke. I need to change what I am sharing, I believe, now. Okay, can you see Trinket? Stephen, can you see Trinket?
So yes, yeah, I can see Trinket.
Okay, cool. Wonderful. Right, and then, so today we're looking at secret messages, and this is the introduction to what we are covering. If anyone has heard of a Caesar cipher, then they will be one step ahead. So this is supposedly comes from Julius Caesar himself, and it's a method of encryption that we'll be looking at today. So what you do is you have every letter of the alphabet, and you can put them in a circle like this.
Piers, would you be able to zoom in? Sorry, you had a query about making the font bigger.
So I did that for Trinket, but I forgot to do it for this. Is that big enough?
Looks pretty good to me.
Okay, cool.
Thank you.
So you've got every letter of the alphabet in a circle, and we're going to start by encrypting the letter A. So that's up here. And we're going to have what we call the key. Now, if the other person knows the key, they'll be able to decrypt your message. If they don't, then they won't. So we're going to use the number 3 as our key. And to encrypt the letter A, we'll count from A 3 times. Once to B, twice to C, 3 times to D. So the answer for A with a key of 3 is D. And the explanation here works out what hello would look like if you do that for all 5 letters, K, H, O, O, and R. Getting text back is the opposite. Instead of adding 3, you subtract 3. So that's what we do. If you put most of your queries into the Q&A, that'll probably be easiest than the chat. I forgot to mention that at the start. Link to the blank Trinket, I can put it in the chat quickly. There you go. So that was done live. Wonderful. So, and I need to take my instructions over here now. Genius. So we'll begin with our program. So we're going to start with the alphabet. So we'll declare a variable. We will name it alphabet. And we're going to put a string in here. And what I've done to help everyone, because it's a fair bit of typing, is I will put into the chat the alphabet for you. And you can put that in there, and you've declared your alphabet as a string. And so each letter of the alphabet has its position in Python, and it's just like some of the arrays you may have seen before. So if we want to print the first item, we start by printing alphabet, and the first item is position 0, because everything starts at 0 in Python. And if we hit run, we get an A for our output. Likewise, if we print something else, such as the 7th character, we should get a G after the A we had before. So, can anyone guess what will be coming up if I ask for number 19? Just give you a few seconds to work that one out. And the answer is T. If you count through, starting at 0, number 19 will be the letter T. Perfect. So the other thing we needed for our Caesar cipher, we'll get rid of those, was our key. So we'll declare a variable called key, and we'll give it a value. This time we'll use 3, just the same as the worked example we went through earlier. And the next thing to do is we will ask the user for a character that they want to encrypt. So we will call that character, and that will equal, and this is a function that Python provides, it's called input. You open up the bracket and then you type a message. So this helps the user know what they're supposed to pass to you. So in our case, please enter a character. We'll put a colon at the end and a space so it looks nice. If we run that, I'll show you what happens now. It just asks me for a character. I type one in, but I haven't written any more code. So nothing else will happen yet. Wonderful.
Piers, could you zoom in again? So to interrupt.
Want some more zooming. Let's see. That's 200%. Is that good? Let's adjust the width of that a bit. How's that?
It's looking pretty good to me. I'll
Okay. Awesome. Right. So our next task is to find the position of the character the user has entered. So in this case, we're going to create a variable called position, and that is going to be the result of alphabet.find. So this is a function that string provides. That's why we have to do alphabet.find. It will apply to the alphabet, which will have these value up here, and we're going to ask it to find the character that the user typed in. And just to show what that does, we will print the position that finds. And if I run this, type in an A, we should get 0. Excellent. If we run it again and type in a T, that was 19 previously, and that's the answer we get. So we have our position. I'll give a little bit of time for people to work through that bit. Something I should point out is that it will only work for things that are in that alphabet. So capital A, which I should type exactly that, and if I hit enter now, -1. That's Python's way of saying it couldn't find it. So if I put anything else that's not in there, such as a question mark, I'll also get -1. So we can fix that later, but we'll ignore it for now. So to do the part of the Caesar shift where we add our key to our position, we need to calculate a new position. So we'll create a variable called new position, and that is going to equal position plus key, because they're both numbers. So that's nice. And then just to have a look at what that equals, we will print new position. And if we run this, passing in A, we'll get 3. And that's what we expect. That's what happened when we worked this out manually with the big circle. And T will become 22, hopefully. Yes, 19 plus 3. Wonderful. Let's have a look what the next step is. So there's going to be one issue if we try the letter Y. The answer is 27, but there aren't 27 letters. So we're going to fix that with the Modulus operator. So we'll put round brackets around this piece. And then if you're on a UK keyboard, it is Shift-5 to put the % and 26. And what this does is it says that if you get 27, treat that as 0. 28, treat it as 1. So we'll wrap around and sort of make a circle of values. So if we try this again, 27 should now be 1. So that's good. That's now a valid character in our alphabet, whereas previously it would have been a problem. And then we can use our new position to get our new character. So we'll declare a variable for that. And that is going to equal alphabet. And we'll use the square bracket. This will index the string like we did when we printed, and we'll get new position. And then, so we can see that on screen, we will print new character. So now our A will become a D, just like it should. And our Y that would have gone off the end, but we've fixed it, is now a B. I'll give another minute for people to catch up if they need. While we do that, we can take out some of our old prints. We don't want these anymore. So we'll just print the result. So if I run that again, we won't get the numbers, but we will just get the answer. There we go. So our next challenge is this key is currently fixed, and we want to take that in from the user. So we'll delete the 3 and say that key is equal to input, and we'll give a friendly message. Please enter the key, colon and space. Perfect. Now, if we run this, we'll enter the key, and I think this will crash at some point after I've entered a character, and it has. So this is because key is currently a string, even though it is the character 3. So what we need to do is say that key is equal to int key. And what this will do is if the string contains only numbers, it'll convert it into the number that we're looking for. Int is short for integer, which is a technical name for whole number. So if we try that exact thing again, pass in 3 and A, this time it works without the error. So I'll let people catch up, and that will be variable keys worked out. So we have a question on the Q&A about handling capitals. Now what we can do for capitals is if we want capital A and lowercase a to be the same, what we can do is at the end of this input, we can do a dot, type lower, and that's a function call. That will convert anything to the lowercase version of itself. So if I take that out again and show you what happens if I type A, oh no, I need to put a key in, type a capital A, it comes up with a C. C is not correct, it should be a D. But you remember when I said that find returns -1 if it wasn't present, and -1 plus 3 is 2, and the 2 index is character C. So if we put our 2 lower in and rerun the code, then a key of 3 with a capital A will give us a lowercase d. And now they'll correctly work out for uppercase letters. So I'll give you a little bit of a breather to get through that. How are you guys finding the pace? Do you want to stick something in the chat, see if you're ahead, behind? Could go faster. Okay, from one person. There are 11 people. We need to find a happy pace for everyone. So there's a question in the Q&A, what if there are strings in the int? And the problem there is that it will crash. And we're not going to cover it today. There are some ways to deal with that. But for example, if I type a character here, you'll get an issue. Invalid literal for int with base 10 h. That's telling you the h is not allowed as part of this number. So what we'll do is we won't do that. Okay, so what I can do, I believe, is get a link to where we are now. And I'll put that in the chat if anyone needs to catch up. And then we will move on. So, oh dear, what have I done? There we go. This is quite laborious. We have to run our program for every character of a message. Let's see how long it takes to calculate hello this way. So I've got to put in the key and the H, and it's a K. Hit start. Same key, mustn't change it, and the next letter. Okay. And you can see where this is going. This is going to take me a while. I can probably skip this. I know I've got to do 2 L's and move on to the O. But that took a while, and we've used for loops before. So we're going to try some of those. But the first thing we want to do is take in more than a single character. So we're going to rename this variable message. And we'll ask the person using the program to enter a message. And that's a good start. Next, we're going to put a for loop in this section. So we're going to do for, and for strings, that will by default take every character in the string. So character in message. So that's what I did manually earlier. I ran the program multiple times. Now all of this we're going to put into the for loop. So you can select it with the mouse and hit tab. That will indent it, and for Python that means it will all be part of the for loop. So now all of this that we did earlier manually will now be done by the code. So if we run, put our key of 3 in and enter an entire message like the word hello, it's printed out each individual character that I had to get manually last time. So I'll give a minute. I've got a timer on my desk, and you can catch up converting to a for loop. Okay, I hope everyone is where we are. What I can do, as this is a bit complicated, this one, is get a new link for this, put it into the chat for everyone, and put it out. So if you want to catch up, you can use that link to get to this point. We've got a request about dealing with characters that aren't in the alphabet, and we will cover that later. But for now, we may as well show you what happens if we do something. So I believe they'll still go, and it's that C again will always pop up for anything currently that's not in there. But we will deal with that later. So what we do need to do is make a printing every line is a bit cumbersome, so we will make new message, and that will equal an empty string to start with. So this is just somewhere for us to put the encrypted things, and after we print the character we can add a line that says new message plus equals new character. Now plus equals will do is the equivalent of, I'll write it underneath, new message is equal to new message plus new character. So it's just going to add new character to new message. But we'll only do that once. And then at the end of the for loop, but outside of it, so we'll hit the delete key to take away the tab, we will print new message. Now if we run that, we should get a nice message. The whole encryption at the end, and we can remove this print, we don't need it, and we'll take a couple of these blank lines out as well. So there we go. You now have your ability to encrypt single words so far, as we haven't supported punctuation yet. You can also decrypt if you put a negative key in, and I think that was the one, and it prints out hello. So there we go. I'll give a minute, need to catch up. All right, we'll add some niceties here. So just a little message. And in Python, if you pass two things with a comma in between, it'll print them both with a space in between. That saves doing that bit. And then that'll just make a tiny improvement. It's always good to have a nice program. And there we go. So we need to deal with this particular issue we have with various things that aren't in our alphabet. You see these 3 C's are a problem. We don't actually want those in there. So what we can do is in here, we'll put a new line in, type if character in alphabet, and then put a colon. And again, we need to highlight all of this, push the tab key, shift it along. And what this will do is it will cause the program to ignore anything that's not in the alphabet. Only things in the alphabet will have this code executed. So if we demonstrate the exact same inputs again, hi there. Now we don't have those 3 C's. But what we do have is we've lost space, and maybe we want that. So what we can do, put a new line and then hit the backspace, type else, colon, and we'll say new message plus equals character. So if we don't recognize the character we've been asked to encrypt, we'll simply use the character unchanged. And that will result in a slightly nicer message, leaving the space here and the 2 exclamation marks. So I'll give a minute to catch up with those changes. So we've come to the end of the scheduled tasks for this program. There are a couple of challenges at the end of the instructions for this that you can do in your own time. And I will post the instructions for this out to the chat. There's something called the friendship calculator. So that will be using the things we've learnt about in this task to do a different task. And that swing. There are some other extensions you could try and do. For example, you could add exclamation mark to your alphabet. And if we also add that, shouldn't be there. This should now allow us to encrypt the exclamation marks. And now they have gone to a C, but that's not because they weren't found. That's just ironically what happens if we put an exclamation mark and a key of 3, because it would have gone from exclamation mark 1, 2, 3. And that's the C. So you can add all sorts. You could take out this lower and add all the uppercase characters if you wanted to. That would allow you to handle those differently. And many other things. You could put a space in here and we can encrypt the space. The sky is your limit. If we rerun that. There we go. So now these are B's and that's a C. So if everyone is doing okay, we will put, what are we supposed to put on there? Reshare this. Which hasn't gone very well. Talk about poorly prepared. There we go. Hopefully. So if you still have any questions, I'm happy to hang around and we'll answer any questions you still have. If not, that is today's session finished. See what you can accomplish.